Hello everyone, and in this video we will be discussing three topics. First we will discuss infix to prefix, then postfix to prefix, and in the end we will be discussing postfix evaluation. So first we will discuss what's an infix expression. An infix expression is one where the operator is in between the two operands. Here the plus is between A and B. So this is an infix expression. A prefix expression is where the operator is in the starting of the two operands. That is, it is of the form operator, operand 1, operand 2. Like here, plus is before A and B. So it's an infix equation. So let us consider an infix expression. X is equal to A into B plus C divided by D minus E. So in order to write the prefix of this equation, first we find out the operator with maximum priority. Here star and divide have this most priority. So for visualization purposes only, what we do, we keep them in brackets and treat them as a single operator in later part. So I can write it as, for prefix it can be written as this one, can be written as AB, let's keep it in bracket itself, into C by D minus E. Why we choose this one first? Because it's on the left side and the direction of the multiply and division operator is from left to right. So I can treat this one as a single operator and this one as a single operator. So what we do, though I did merge two steps in it, first we have to solve this one, then we will solve this one, but I just solved them all together. So what we can do is, we can write it as T1 plus T2 minus E. Now both of them has same priority, so since the direction is from left to right, we keep them in bracket. Though the real bracket doesn't exist, we are doing it only for the visualization purposes only. And we solve this one, it will be of the form for T1 T2 minus E. Now we can treat this one as a single operator and write it as T3 minus E, which can be further written as minus T3E. Now this is the required prefix equation, but since we didn't start with T3, we will keep expanding. So in place of T3 we write minus plus T1 T2 E. Also we will write T1 and T2 as minus plus AB, and this is the required prefix expression. Now we will discuss how to convert infix to prefix using stack. So the first thing we will have to do is, we will write this expression in the reverse order, that is E minus D divide C plus B star A. And now we will put the inputs. Here we will show the top of the stack or the whole stack, and here the output expression. Actually here I did a mistake. T2 would not be C by D, it would be of the form by D. So the correct prefix equation would be minus plus star A B divide C D E. Now let us convert this by using stack. So first we have the input E. E is an operand, so it will go in the output itself. Then we have the minus operator. Since the top of this stack is empty, we will write here, and we will write E in the output. Then we have D. We write D. The stack top remains the same, and then we have D here. Then we have the division operator. Now the top of the stack is the division operator, and here we have E and D. Now the next input would be C, so we have C here minus E D C. Now the next input would be the plus operator. Now we know that the priority of the division is more than the plus operator, so we will pop out the top of the stack, that is we will write it as E D C and then division, and we will see if the current top, that is the minus sign, has the same or more priority than the same or less priority than the incoming operator. Since they have the same priority, so we'll write the top of the stack as plus. The next input would be P. We write it E D C divide P, and here we have plus. Then the next input is star, so we write it as minus plus. Since the star has more priority than the plus, we will write it as a top, and then E D C B, and the last input would be A, and the stack would be this, and we will write it as E D C B A. Now since the inputs are over, we will just empty the whole stack in 3 steps. First we pop out star, it would be star plus, and E D C B A. Then we have minus, sorry we won't have this, we pop out this one, we have E D C, and then we finally pop out star, and we'll have the expression as E D C B A star plus minus. But the actual prefix equation would be the reverse of this equation, that is x is equal to minus plus star A B, then we have division C D E, which is the same that we achieved in the first step, that is here. In the next topic is prefix to postfix conversion. So in order to change a prefix equation to a postfix equation, what we do is we first change it into a infix equation, and then we change infix to postfix. So we have the operator star, and then these two can be considered as individual operands rather than expression. So to convert it into infix, what we will write is we will write A B using brackets for better visualization, and C D. Now these two, we consider them as operands, but they were actually expressions, so we will further solve them, and they can be written as A plus B C minus D, which is the required infix equation. Now what we can do is we have to change this infix into a postfix equation. So we write it as the most priority element is this one, the star, so we consider them as individual again as operands rather than expressions. So we write it as, to write postfix, A plus B C minus D star. Now what we do, we solve these two also. These two can be solved as A plus B can be written as A B minus, though we do require two steps to solve this. First we solve this one and this one, but I'm doing it in one step. And we write c d minus and then we write star, which is the required postfix equation. In order to do this in stack, first we write the prefix equation in reverse order, which would be d c minus b a plus star, and we start pushing the elements into the stack. So the input is d, we push d into the stack, then the next input would be c, we push c and d. Now the next input would be in the minus, so we pop out the first two, the top two operands, and that is d and c, and we write them in a postfix equation, and then we push them again. So d and c, what we do, we pop out c minus d, which will be equal to, and concatenate again, so it would be dc minus. Now we take the next element, that would be b, so we write b. Now we have to consider this one as a single operand rather than an expression, which will be more useful. So we have to write c d minus, and we have b, then we have a, so we have c d minus b a. Next one is plus, so we have c d minus b a, and since it's an operand, so it will pop these two and then writing them in postfix and then concatenate again, so it will be minus a b plus I did a mistake here, it should be plus here, I just realized that, so it would be. Now the next one is a operator again. Now since we, as I said again, we will consider them as individual operators, so this will pop out the next two operators, the top two operators. That would be, the first operator would be cd minus, and the next operand would be cab plus, and then it will write them in a postfix expression, concatenate them in postfix expression, and then push them back in the stack. So this would on whole would look like something like this: ab plus cd minus and then a star. Since we have emptied all our inputs, so this is the required postfix expression, that is a b plus c d minus star, which is the one that we get above in the answer. In order to evaluate a postfix equation using stack, let us consider an equation 2 3 1, let's say star plus 9 minus. In order to apply postfix evaluation using stack, let us consider the equation 2 3 1 star plus 9 1. We write input stack. So what we do, the first one is we write the input as 2, and since the stack is empty, we write it as 2 itself. The second one is 3, which is again an operation, so we write 3 in this stack. The next one is 1, which is again an operator, so we write 2 3 1. Now we have star, which is an operator, so we pop out the two operators 3 and 1, and then first we pop out the two operators, apply star and write the answer. So 2 star 1 3 star 1 will be 3, so we write, we push the answer again into the stack, so we write as 2 3. The next one is plus, so we write it as plus. We pop out the two elements, which are 2 and 3, and we add them, so it would be 2 plus 3. So we have the answer, and the answer would be 2 plus 3, that is 5, and we push it back into the stack, then the top of the stack would be 5. Now the next element would be 9, so we put 9 here. Since it's an operand, so nothing happens, it just goes to the top of the stack, then it will have 9 here. And the next one is an operator, that is the operator is minus. So what it does, it pops out 9, we have 9 here, then it 1, and then it pop out 5, so in this way, and then the answer would be 4. And the answer of this expression, this postfix expression, would be hence the top of the stacks left at the end, that is 4. So we can write here answer is equal to 4. So these all are my 3 topics. Thank you very much for listening to me.